Let's switch gears to Newton's third law. Newton's third law is famously stated as, to every action there is always an equal and opposite reaction. This is probably the most famously but also the most misunderstood of the three laws. The key thing to remember is that the action-reaction force always acting on two different objects. So there are always two objects involved in Newton's third law. The action force is from A to B, then the reaction force has to be from B to A. Newton's third law can be verified in our physics lab using two force sensors. As you can see from the experiment outcome, the force on those two force sensors are always equal magnitude and opposite direction. Let's take a quiz, trying to understand what Newton's third law says. Now we ask, a small toy car runs head-on into a real truck, like a semi-truck. Did the toy truck exert more force on the truck, or the truck exert more force on the toy car? What's the answer? The answer is neither. The force the truck exerts on the toy car is exactly equal in magnitude to the force the toy car exerts on the truck based on Newton's third law. Because those two forces are an action-reaction pair. The reason the toy car, gets more damage is because it has much smaller mass. So it's more vulnerable. Newton's second law is all about the forces on a single object. Now keep in mind, Newton's third law is concerning with two objects. So let's study this real-life situation. In the first scenario, a catcher catches a baseball to make the ball start moving. Okay, so think about that. Did the hand apply a force to the baseball to make it stop moving? Answer is yes, right? Apart from that, why the catcher always wear gloves? Now, one reason, of course, to increase the successful rate of catch, but also to protect the hand, right? Because the force from the ball to the hand can be large as well. And think about the train wreck, the train bumping into a bus in this case. The train will apply force on the bus, but the bus will apply force on the train as well. And then the third scenario, a satellite orbiting around the Earth. We all can imagine the Earth is applying a force we call gravity on the satellite. But we have to ask, did the satellite also apply a force on the Earth? Based on Newton's third law, the answer has to be yes. Yes, the satellite is attracting the Earth. Then the magnitude of the force has to be exactly equal to the weight of the satellite, right? Based on Newton's third law. Now in this slide, we just explicitly draw as illustrate what is the action-reaction pair of force looks like. It's well known that the moon is orbiting around the Earth, but actually more precisely, both the moon and the Earth are orbiting around the center of mass of the Moon-Earth system, which in the picture is the green dot. Actually, the Earth is spinning around this green dot as well. And the center of the moon's motion actually is not the center of Earth, but this green dot in this picture. So the Earth is orbiting around this green dot. The moon is orbiting around this green dot. That's because not only the Earth is applying a force and the Moon as well, the Moon is also applying a force on the Earth. Let's try to do another quiz. A water skier is being pulled by a rope attached to a speedboat moving at a constant velocity. Consider those four forces. The force of the boat pulling the rope, the force of the skier pulling the rope, the force of the boat pushing the water, the force of the water pushing the boat. Which two forces are an action-reaction pair that is consistent with Newton's third law of motion? So what is the action-reaction pair? So it has to be between two objects, right? It has to be between two objects. If action is from A to B, then reaction is from B to A. We cannot have a third object. And they have to be equal magnitude, opposite direction. Based on that criteria, I think the only two forces satisfy this is 3 and 4. The force the boat pushing the water, the force the water pushing the boat, involving two objects, and the force between them are equal magnitude, opposite direction. Another quiz. During a boxing game, Mayweather punches Pacquiao on the face with force F1, and Pacquiao punches back on Mayweather with equal magnitude F2, F1, F2, action-reaction force, opposite direction and equal magnitude, are they? The answer actually is no. So look at this force. That's the action force, and the reaction force has to be from the face to the face. And the same applies to here. So there are actually two pairs of action-reaction force in this particular example. Now, actually, Newton's third law can help us explain how did we jump or walk. Think about how do you walk. What's the direction of the force you apply to the ground? If you pay close attention, actually you are applying a force backward. Your force is backward. So the ground then will apply a force as a reaction force, pushing you forward, right? And if you want to jump, think how did you jump? What's the first thing you do? You want to jump, you bend down, and you apply a force. You apply a force that is pointing downward on the ground. And the ground will react with the force pointing up. And if that reaction force overcomes gravity, you jump it up. Now, another conceptual quiz. We have Superman and Supergirl doing tug of war. No one is winning. Then how does the friction force on Superman and Supergirl compare? No one is winning, which means they are not moving. So the force on Superman, let's call it force on Clark. The force on Superwoman, let's see, the force on Kara. Now, none of them are moving, so which means the net force on Superman has to be 0. So this tension has to be exactly cancel this one. Now, because it's on the same stream, so this tension has to equal to this tension, but the net force on Supergirl has to be 0 as well. So this one equals tension, and the tension equals force on Clark. So those two forces has to equal each other. The answer is B. Now imagine if we put both of them on skateboard and ask them to do a tug of war, who is going to win? The force between them would be the same as we discussed, because it's just the tension. And we just assume Superman is heavier and stronger. If force is the same, who has larger acceleration? Who will get a larger acceleration? Because Superman has more mass. Supergirl has less mass. So Supergirl will have a larger acceleration compared to Superman. And if Supergirl has a larger acceleration, so it's likely Supergirl will cross the middle first. So I would see Superman is going to win this tug of war. Okay, I think those examples are helpful for us to understand Newton's third law.